the Unit 1 Rational Numbers test review. Number 1, which best describes the classification for the following set of numbers? So out of this set of numbers right here, I have to determine if they are rational, integer, or whole, or more than one of those, or all of the above. So let's look at this first number, -4. Well, I know that -4 is automatically an integer because it can be found on a number line. Okay. I know rational numbers are any number that I've ever learned about. So if I look through here, I have learned about all of these numbers. So that is a rational number. Also, those are all rational numbers. 5 can be found on a number line. 8, -15, -20, and 32. So those are all integers. Now if I'm going to whole numbers are numbers that we can count on our fingers. So if you look here, I can't count -4 on my fingers. I know whole numbers do not include negative numbers. So I know number 3 is not going to work. So if I look over here at my answer choices, anything with a 3 in it I can take out. So I know it's not B, and I know it's not D. So all I have left is 1 only or 1 and 2 only. Well, if we look over here, we said these were all rational and they were all integers, so C would be my answer. Number 2, Jose was asked to convert 4/5 into a percent. This is his work below. Find his mistake and using complete sentences, explain what he did wrong and give the correct answer. So remember when we're changing fractions to percents or any of those, we use FDP, fraction decimal percent. To change a fraction to a percent, we have to change it to a decimal first. We can't skip this. So remember to change a fraction to a decimal, we typo. That means top in, bottom out. Add your decimal, take it up into 0. 5 won't go into 4, but it does go into 48 times exactly. So 0.8 is now my decimal. And then change a decimal to a percent. I like to sing that song, I like to move it, move it. You know, the one from Madagascar, that's how I remember how many times to move it. So you move it 2 times to the right, okay, because decimal to percent is to the right. So move it, fill in my 0, so 80% should be my answer. So let's look over here and see what he did. Well, I noticed right off the bat that he put the 5 inside of his house instead of the 4, so he did not follow typo. He divided his fraction incorrectly. So we can say that Jose divided his fraction incorrectly. If I were going to continue to give the correct answer, I would say when he divided, should have left more room for myself over here. He should have gotten 0.8, which equals 80%. Okay, number 3. During a lesson in math class, Charlotte was asked by her teacher to determine where 4 would lie in the Venn diagram. Which of the illustrated Venn diagrams shows the best placement of 4? Let's start whole numbers. Whole numbers we can count on our finger. Can we count to 4 on our finger? 1, 2, 3, 4. We can. So 4 is a whole number. Can 4 be found on a number line? Yes, so it's also an integer. And I've learned about the number 4, so it's also rational. So this 4 needs to be in all 4 of these circles. So if I look at my options, this one is only in whole number. This is only in whole and integer. This is in whole and rational, and this one has it in all 4. So the answer here would be D. Backside. What is 45% expressed as a simplified fraction? So again, our FDP, they want us to go from percent all the way back to fraction. So in order to do that, I have to change it to a decimal first. So remember, we're going to move it, and I'm going percent to decimal, which is that way. So 45%, this does not have a decimal right now. So if we're going to add a decimal to this, we always add it at the end because that keeps 45 as a whole number. So like we said over here, we're going to move it 2 times to the right. Now I have 0.45. And then to go from decimal to fraction, it's write it like you say it. So how do you say 0.45 using your place value? Well, this would be the tenths and the hundredths. So this would be 45 hundredths. I don't know if any of you remember that little trick I taught you. There are 2 numbers behind a decimal, so that means I need 2 zeros here. That's a way you can check yourself. Now I know I need a simplified fraction, and this is not in simplest form. Anything that ends in a 5 or a 0 can always be divided by 5. So I'm going to divide both the top and bottom by 5. 45 divided by 5 is 9, and 100 divided by 5 is 20. If you didn't know 100 divided by 5, you could just come over here and do your long division. 5 won't go into 1, but it will go into 10 2 times. 10 minus 10 is 0. 5 goes into 0 0 times. So that's how you could get 20. Now looking at this, I know the only thing that goes into 9 is 3, and 20 does not go into 3. And I know 1 times 9 also gets me 9, but 9 does not go into 20. So this is in simplest form. Okay, number 5. The set of whole numbers includes all the following except. So remember, whole numbers are numbers we can count on our fingers. So I can count to 6. I can have 0 fingers. I can count to 8, but negatives are not included in the whole numbers. Number 6, what is 6.7 expressed as a percent? So here we go with the FDP again. I have a decimal. I wanted to change it to a percent, so I'm going to move it, and I'm going from decimal to percent, which is to the right. So 6.7, move it, fill in a 0. That leaves me with 670%. Number 7, which of the following sets can each number, which of the following sets can each number only be classified as rational? So rational numbers are basically any number we've ever learned about. We know that. But to only classify it as a rational number, that means it cannot be an integer, which are positive and negative whole numbers. So those are integers. And then numbers that we can count on our fingers are whole numbers. So I need to find a list that does not include all whole numbers and integers. So if I look here, this has a whole number, an integer, and then some rational numbers. Remember, rational numbers are both of these plus fractions and decimals. So if it can only be classified as rational, I know that's going to have some fractions and decimals in it, or they all have to have at least fractions and decimals in it. So if I look here, like I said, these have whole and integer, so it can't be this one. This one has a decimal, and there's an integer, so it can't be that one. Fraction, 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 fraction. This one looks good so far. None of those are integers or whole numbers. And then I've got decimal, 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 whole number, so it can't be this one. So our answer here would be C. Number 8, which list of integers is in order, from greatest to least? So when I'm thinking of integers, I know those are positive and negative whole numbers. If I'm going greatest to least, I'm going to start with my positives and move to my negatives. So if I look here, knowing this, I need to start with positives, I can automatically eliminate A and B because they start with negatives. So that leaves me with C and D. So biggest to smallest, so 15, then 3, then 0, then negative 6, and negative 9, or 15, 3, 0, negative 9, negative 6. Now if we look at our positives on both of these, we know that that's correct. So it gets a little tricky when we get to our negatives. We just have to remember that the number that's closer to 0 on a number line should come next. So if I had my number line here, here's 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's negative 9. Here's negative 6. If I continued out my positives, there's 3. And then 15 would be way over here. I know that's not even, sorry. So if I'm going greatest to least, to go 15, 3, 0, negative 6, then negative 9. So C would be my answer. Number 9, simplify the expression negative 32 minus 14. So if you look at your green integer rule paper that we gave you, we'll notice that this is a subtraction problem. And with a subtraction problem, we always keep, change. So I keep the negative 32. I change subtraction to addition, and I change positive 14 to negative 14. Now I have an addition problem, so I can follow my addition rules. I have to ask myself, are the signs the same or different? Here they are the same, they're both negative, so when they're the same, you add the numbers together. You get 46, and you keep the sign, so negative 46 would be your answer. Okay, number 10. Simplify this expression, 6 minus 5 parentheses negative 4. Well, if you remember, 5 parentheses, a number next to parentheses means to multiply. And then if you think all the way back to your PEMDAS rules, you're going to do multiplication before you do the subtraction. So we have to do the multiplication first. Remember, with multiplication, we can use our sleeping man. So I have 5 times 4, negative 4. Well, 5 times 4 is 20, and a positive times a negative is a negative. So this is negative 20. So I have 6 minus negative 20. Well, just like on number 9, this is a subtraction problem. So I'm going to keep, change. I'm going to keep the 6, change subtraction to addition, and change negative 20 to positive 20. Addition problem, my signs are the same. They're both positive, and we know what 6 plus 20 is, so 26 is my final answer. Number 11, which of these expressions has the greatest value? So let's solve these. This is a subtraction problem. I'm going to copy it out here. With the subtraction problem, I keep, change. So I have negative 8, I keep, I change subtraction to addition, and I change negative 4 to positive 4. Now I have an addition problem, so look at your addition rules. Are my signs the same or different? They're different. This one's negative and that's positive. So when they're different, you find the difference, or subtract. So the difference between 8 and 4 is 4. And I have a negative 8. I have 8 negatives and 4 positives, so I have more negatives, so negative 4 would be my answer for this one. All right, let's look at B. Negative 8 plus negative 4. Addition problem, so go straight to your addition rules. Are my signs the same or different? They are the same. They're both negative, so when they're both the same, you add the numbers together and keep the sign. So this one's negative 12. Let's look at C. Negative 8 times negative 4. Okay, multiplication problem. Remember, the dot means to multiply. 8 times 4 is 32. If I came up here and used my sleeping man again, because you can only use that for multiplication and division, a negative times a negative is a positive. So this is positive 32. Then last but not least, I have division. Negative 8 divided by negative 4. Same rules, sleeping man apply. 8 divided by 4 is 2, and a negative divided by a negative is a positive. So that's positive 2. I'm looking for one with the greatest value, so the biggest number out of all these would be positive 32. Number 12, which of the following expressions is equivalent, we know that means equal, to negative 12? So let's solve these expressions and find the ones that are equal to negative 12. So here we go, negative 84 divided by negative 7. So I can use that sleeping man again because this is a division problem. 84 divided by 7 is 12, and a negative divided by a negative is a positive. So that's positive 12. I want a negative, so I know it's not this one. Let's look at number 2. Remember, a number next to parentheses means to multiply. 2 times 6 is 12, but then I have a positive times a negative, which is a negative. So this one is negative 12, so we know this one works. Let's try number 3, 14 minus negative 2. This is a subtraction problem, so I'm going to keep, change. Keep 14, change subtraction to addition, and change negative 2 to positive 2. And 14 plus 2 is 16. We don't want that. We want negative 12. Okay, let's look at number 4, negative 22 plus 10. This is an addition problem, so go to your addition rules. Are your signs the same or different? They are different. That's a negative, that's a positive, so I'm going to find the difference between the two numbers, or subtract. 22 minus 10 is 12. And then what do you have more of? You have 22 negatives and 10 positives. So you have more negatives, so negative 12. So this one works also. So 2 and 4 would be our answer. Number 13, simplify the expression. Remember the line, this looks like a fraction, and the line in a fraction means to divide. So 56 divided by 8 is 7. Okay, and then a negative divided by a positive, if I use my sleeping man, is a negative. Number 14, simplify this expression. I have a bunch of numbers in parentheses with no operation in between them, so that must mean to multiply. So let's just chunk it out and do 2, get an answer, and then multiply by the third one. So I'm going to do 4 times negative 3. Well, 4 times 3 is 12. This is multiplication, so I can use my sleeping man. I have a positive and a negative, so that's a negative 12. And now I can bring down my negative 5. So negative 12 times negative 5, well, I know 12 times 5 is 60. And then a negative times a negative is a positive. So positive 60. Number 15, Evan has $40 in his bank account. He spends $5 each day on breakfast tacos on his way to work. What is Evan's bank account balance after 2 weeks of buying breakfast on his way to work? But note, they say here that he goes to work only 5 days a week. So 2 weeks of 5-day work weeks would be a total of 10 days. So if he spends $5 each day for 10 days, that's 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. That's 10 days. Well, faster way to do that is 5 times 10, which is 50. So he has spent $50. He started with 40. He spent 50, so subtract because he spent it, 50. So 40 minus 50, well, this is a subtraction problem, so keep change, change. Keep your 40, change subtraction to addition, change positive 50 to negative 50. Now follow your addition rules. Are your signs the same or different? That's positive, that's negative, so they're different. So I'm going to find the difference between the two numbers. 50 minus 40 is 10. And I have 50 negatives and 40 positives, so I have more negatives. So he has negative $10 in his bank account. That is not good. He overspent. Okay, this side, number 16. Which value is greater than 62%? So we're looking for something that's greater than 62%. So I see fractions and decimals here, so I'm going to write my FDP down. I always like changing my decimals to percents first. And remember, when you're comparing numbers like this, always change everything to a percent. It's so much easier to look at whole numbers because percents are whole numbers. All right, so like I was saying, I like to change decimals to percents first because that's just a simple move it to the right. So if I look at this one and I move it, that would be 61.3%. If I think of this like money, that's $61.30 and that's $62. This is definitely not bigger. Let's do this one. Move it. That gets me 62%. Well, those are equal, but it's not greater, so it can't be this one. So let's start looking at our fractions. Let's do B, 3/5. So in order to go from fraction to percent, remember we have to change it to a decimal first. And fraction to decimal is typo, because a line in a fraction means to divide. So top in, bottom out. Add your decimal, take it up in a 0. 5 will not go into 3, but it goes into 30 exactly 6 times. 6 times 5 is 30. So I have a decimal of 0.6, but to change it all the way to a percent, I'm going to move it, fill in my 0. So this is 60%. 60 is still not greater than 62. So it looks like C is our answer, but let's just double check to make sure. Top in, bottom out. Decimal, take it up in a 0. 9 will not go into 6, but it does go into 60 6 times. 6 times 9 is 54. 60 minus 54 is 6. Add a 0, bring it down. Here I go. Again, 60. That would be 6 times. 60 minus 54 is 6. Add a 0, bring it down. You see how it keeps repeating. I think I'm going to stop here. Go move it. That would be 66.6%. And 66 is bigger than 62, so we were right at C. Number 17, after the first round of a golf game, Taylor had a score of -9 points, okay? She scored 5 points on the second hole, so she added 5 to that. Okay, so if I'm at -9 and I add 5, let me write this out this way, sorry. I'm going to ask myself, this is an addition problem, so are my signs the same or different? They are different, so find the difference between the two. The difference between 9 and 5 is 4, and I have 9 negatives and 5 positives, so I have more negatives, so this is a -4. Okay, let's keep going. She scored 6 points on the third hole, so add another 6. Addition problem, so are my signs the same or different? They are different, so we're going to find the difference. The difference between 6 and 4 is 2. I have 4 negatives and 6 positives. There are more positives, so this is a +2. Bring it down here. Sorry, I need more room. And then on the fourth hole, she scored a -3, so I'm going to add a -3. Okay? Are my signs the same or different? They are different, so we're going to find the difference between 3 and 2 is 1. I have more negatives, so -1. Now it says that we need to record our answer and fill in the bubbles on the grid below. Be sure to use the correct place value. So I'm going to go over here and bubble in my negative and write it up here. Remember, it's very important that you write and bubble. You need to do both of those things. And then this 1, if I were going to add a decimal to this 1, remember we always add a decimal behind our whole number. So if I do that, then I can look up here and I can see, oh, okay, my 1 goes here in front of the decimal because it's a whole number. So make sure you mark your negative. If it's a positive, you don't have to mark your positives. But if it is negative, you need to make sure you bubble in your negative and write it up here. Number 18, record the set of numbers in ascending order. So ascending is maybe a vocabulary word that you may not quite know, but the opposite of ascending is descending. And we know descending means to go down. They both start with a D, so ascending must mean to go up. So I'm going from least to greatest. I'm getting bigger. So I see fractions, decimals, and percent, so I know I'm going to need my FDP. Remember to order, we always like to change them all to percents. It's much easier that way. I already have a percent, so I'm going to write it over here. Okay, and then if you remember what I said a couple questions earlier, I like to change my decimals first because it's just a simple move it to the right, because decimal to percent is to the right. So I'm going to move it, 0.04, move it, ends up right behind the 4, so that would be 4%. You know what? I should probably write them above it. That way we can remember what it came from. 4.02, move it, that's 402%. Okay, now all I have left is my fractions. So remember to go from fraction to percent, we have to change it to a decimal first. And to do that, we typo. Top in, bottom out. I'm doing this first fraction. Add your decimal, take it up into 0. 5 won't go into 2, but it does go into 20 exactly 4 times. So that gets me 0.4, and then I'm going to move it. Fill in my 0, so 2/5 is 40%. And then last but not least, I have 5, 6, so top in, bottom out. 6 will not go into 5, but it does go into 50 8 times. 8 times 6 is 48. 50 minus 48 is 2. Gotta keep going. 6 goes into 20 3 times. 3 times 6 is 18. That leaves me with 2 again. Oh, here we go. It's going to start repeating. So I'm going to stop here because if you remember, we really don't ever make you go past the third decimal. And then change it to percent. I'm going to move it. And that gives me 83.3%. So if I'm going in ascending order, least to greatest, I need to look and see what was smallest. So I have 40%, 4%, 45%, 83.3%, and 402%. So my smallest percent is 4%. But remember, when you're putting these in order, you need to write the original number. So 4% came from 0.04. We just changed them to percents to help us put it in order, but when you write your answer, you need to use the original numbers. I'll mark that out because I've used it. Next, if I'm looking, 40% comes next. That came from 2/5. Then after that, I've got 45%, which was the original number. And then after that, 83 is definitely smaller than 402. So 5/6 from the 83, and then 4.02. So there is my final answer. Number 19, almost done, 2 more. Convert 2/8 to a decimal. So we're going fraction to decimal. So we're going to be using that typo. Record your answer and fill in the bubbles on the grid below. Be sure to use the correct place value. So 2/8, typo, stands for top in, bottom out. Add your decimal, take it up into 0. 8 won't go into 2, but it does go into 20 2 times. 2 times 8 is 16. Subtract, you get 4. Add a 0, bring it down. 8 goes into 40 5 times. 5 times 8 is 40. Now I have a remainder of 0, so I can stop. So as a decimal, that would be 0.25. So going over here, remember I said if it's positive, you don't have to mark this. If it's negative, you do, but since this is positive, we're not worried about it. Here's my decimal, and here's my decimal. That 25 comes after. Remember to write and bubble. Very important. I need it in both places. Okay, and then last but not least, 3 weeks after planting seeds in a garden, Ryan and his mom measured the heights of several of the vegetables that had sprouted. The following chart shows the data they collected. Order the plants from tallest to shortest, so greatest to least. That's important. So I see fractions and decimals here, so FDP, let's change them all to percents first. Let's do our decimal first. Much easier, move it, move it. That'd be 261%. Now, let's start with tomatoes. Fraction to percent, we got to change it to a decimal first, so we're going to typo, and then we'll move it, move it. So top in, bottom out. Add your decimal, take it up into 0. 10 won't go into 2, but it does go into 23 2 times. 2 times 10 is 20. Subtract, you get 3, bring down your 0. 10 goes into 30 3 times. Minus 30 is 0. Do you see how bringing that decimal point up in the very beginning is important? Because a lot of people make the mistake and they put it right here because they try and add it once they're done dividing and it ends up being the wrong spot. So please make sure you take that straight up before you even start your division. So I have 2.3, and when I move it, I get 230%. Okay, 2 3/5. I have a whole number, so if you remember, we always take our whole number to the answer box or wherever you're going to write your answer. So then all I have left to do is typo my 3/5, top in, bottom out. 5 won't go into 3, but it does go into 36 times. Exactly. So I'm going to add my 0.6 here, and then I'm going to move it. That gets me 260%. Last but not least, I'm going to bring my whole number 2 to my answer box and then typo my 1/5, Add your decimal, take it up into 0. 5 won't go into 1, but it will go into 10 exactly 2 times. Add my 0.2 back, and then I'm going to move it, fill in my 0, so this is 220%. So if I'm going to order them from tallest to shortest, what's my biggest percentage? 230, 260, 261, and 220. It looks like zucchini comes first. Okay. I'm going to mark him off, then squash. And if I'm going down, 230 would come next, so tomato. And last but not least, red bell pepper, shortening that. All right, guys, this is your test review. Remember, your test review is almost identical to your test. So if you can go through and study this, and what we mean by studying is covering up the answer, reworking the problem, and then checking yourself. If you can do that, and you do that through all 20 of these, you should be A-OK on your test tomorrow.